So, for next 45 minutes, crypto means cryptography. Okay? Okay? Not cryptocurrency, not blockchain, no, cryptography. Okay. And before we start, let me ask you, are there any security people here, like blue team, red team, pen testers, auditors? Okay. DevOps, DevSecOps, maybe? Okay, people, who are you? Engineers? DevOps, no? Yeah? Architects? PM. Why not? Okay. So I'll have just a couple of questions in my talk, a couple of slides with like very security related slides, but no worries, you can lie to me that you know the answer, okay? So this talk gonna be a cryptography talk, but very high level cryptography talk. No worries, no ciphers, no math. Okay, no ciphers, no math, just security design. And we're going to talk about building multi-layered defenses for your data. So through the whole domains of security, now we're going to be focused on data security. Okay, got it. Awesome. My name is Anastasiia, and I was developing mobile applications for ages. And at some point, That's an expected side effect. All good? Can I continue? Yeah? Okay. So, at some point, I switched to security, and I'm working as a security software engineer. And now my title is product engineer or like chief product officer, if you want, at a company that makes security solutions. So I kind of balance between a world of cryptography and shiny ciphers, modern ideas, yada yada, and applied engineering, people that don't have, PhD in cryptography but still want to create secure applications. I work in a company called Kozak Labs, and Kozak Labs, we came from R&D and military crypto, and we kind of making tools with like military crypto tools. We try to make them accessible for SMEs, for startups. And first we thought that if we're gonna take modern cryptography and give people easy to use modern cryptography, developers will be very excited to use it and it'll be fine. No, it's not working this way. No. And instead of trying to teach developers to create more secure applications, we were like, okay, we will create tools, easy to use, hard to misuse. So if you don't have any security team at your company, still applying the right tools in the right way, you will be able to lower risk of security incidents and high the bar for attackers to grab your data. And by the way, in this presentation, I'm going to have a lot of links and a lot of charts. So the slides are already available online. If it will be complicated for you, to see all of them, you can scan the QR code and have the slides on your phone. Okay, good. This is our plan, and for the next 40 minutes, we're gonna review few steps. First of all, I will explain the current regulations about data security in the market. Then we will take a look on risk and threats of modern web architecture. Discuss defense in depth idea, how to apply defense in depth for your data, and what is more important, which tools to use, because obviously. First of all, have you heard defense in depth before? Do you know the term defense in depth? Raise your hand. You can lie to me, no worries. Okay. Have you read any of these books? No. Expected. So defense in depth is not something new. Basically, in the cybersecurity, there are no new terms. All these terms are from the warfare. So defense in depth, but in computer science, defense in depth we use when we were talking about network security, about creating intranets, creating perimeters, yada yada. And now we switch approach, we switch angle a little bit, and we're talking about defense in depth for data. not only for your network, not only for your infrastructure. Why we care about data? Well, obviously. First of all, if we don't care about data, we're gonna have regulations are pushing on us, right? And the fines are crazy, competitors can steal our databases, you know all the things. And of course, users also will be upset. What I really like, well, because I'm working in data security, obviously, what I really like that regulations starts pushing on large companies, on large providers. And if you as a company is using service by service provider, service providers starts pushing on you. I'll explain it a little bit later. You know GDPR. And if someone will say you that GDPR is all about checkboxes and emails, show them this slide, because GDPR is also about encryption. Article 32 and 35 is about data processing and data encryption. Article 33, 34 is about monitoring in case of data breach, in case of incident. Article 32, taking into account yada, 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 you should use pseudonymization and encryption of personal data. You know the difference, right? You know what pseudonymization is. Lie to me. Yes, awesome. Yes. Awesome. Right. So, if someone will tell you, okay, GDPR doesn't have anything to do with encryption, no. Article 32, it does. But GDPR, it's a regulation about human rights. It's not like a technical law, and it doesn't state what kind of ciphers to use, what kind of protocols to use. By the way, in some countries, like GDPR is umbrella regulation, right? So in some countries, they created their own internal law, internal regulations based on GDPR with indicating exact ciphers. Like in Portugal, for example, they have their own law and they actually put what ciphers to use. And I don't know, like they put really old cipher there, not the state of the art. I don't know how Portuguese companies, at least governmental companies, how they will handle it, but so GDPR doesn't say us anything about what kind of ciphers to use, and what kind of encryption to use, but US Department of Defense does. Last year, they released a document, their document, internal, how to build software correctly, how to build software that US Department of Defense would use. Right, so software for themselves. And this document contains 10 principles. So that software will be better and will be faster, and Department of Defense will be cooler than all the attackers and adversaries. It's very interesting to read. There is a link here. And 10 principles. Principle number 9 says that data should be encrypted all the time, except for short moments it's being computed. Which means that TLS is not enough. Which means that database encryption is not enough. Which means that TLS plus database encryption is not enough. Data should be encrypted all the time except it's being calculated, it's being processed, right? So data should be encrypted per application, per user, and only some trusted services can decrypt it. Which actually sounds cool, but there are apps for that. I mean, it's not something unrealistic. It's a totally realistic thing. And if you heard that MongoDB released field-level encryption recently, like yesterday, I don't know, I'm jet-lagged, I don't know which day was that. So they released field-level encryption, and they said like, wow, field-level encryption, you know, for each database field. It's so awesome, it's so modern. Come on, people, tools are already here. Like, for example, our things, which is open source and free, is already 3 years on the market. It's not so new, it's not so modern. Well, anyway. Remember I told you about service providers that are pushing on companies that use them. For example, Google. Google says, this is really fun. Google says that if you're a company that uses Google API to collect data of Google users and store this data on your own servers, you must, as a company, you must do security assessment and provide the results of security assessment to Google. And security assessment, Google expect that security assessment may cost between $15,000 and $75,000 for you as a company. And you pay this money not to Google, no, but to the companies that will do security assessment for you, which Google will have, obviously will have some list of totally, independent companies. Anyway, some of our customers receive this kind of emails, and now they need to do the security assessment and to show something till the end of the year. And Google is doing this really pushy, I would say so. Apple, for example, they don't do this pushy way. They just update security policies very slightly, and if you're doing apps, if you're uploading your apps to the App Store, you can see how data security policies are being changed. Like now your application, if this application is for kids, you can't use any ads. You can't add any analytics or ad trackers to your app, right? So Apple is pushing these things in a more comfortable way, I would say. And of course, you have heard about OWASP top 10, right? Lie to me. Yeah. Awesome, awesome. When we are talking about data protection, what exactly we are going to protect? Because there are different kinds of data. We all know about user data, which is business data, which is valuable data for our business. Okay, easy. We often forget about service data, because PMs usually don't know that our services separate some kind of technical data, like API tokens and keys. And this data protection of these pieces are usually not a Jira ticket. And developers, they tend to, to forget that they have this data as well. But in the real world, we operate different classes of data, and all of them we need to protect, because losing this data will have different impact on our company. Losing customers' data, obviously, it's a compliance risk, legal risk, we can be sued. But losing technical data, using service data, means that someone can calculate bitcoins on our server sites. Not so good as well. Okay. This is very important slide. Customers usually, end users usually don't have a way to understand how good you do data protection, so it's your responsibility. Now let's get to more technical side of things. If you want to make a photo, yeah. Oh, good. Okay, so charts. This is oversimplified web architecture. Just, a little bit simpler, as you probably have in your apps. But what we have here is a data flow. So the data is being generated on a front end, on some web application or mobile application, and it gets processed on application backend, and usually it's not like one server, it's usually the whole infrastructure, and in the end the data is being stored somewhere, right? And we can also say show this as a layered model. In a typical security design model, the attackers are only outside, and they will need to pass through all our components to grab the data. There are dozens of components, attacks for each component for Node.js server, for example. But some attacks are very special, like SQL injection. SQL injections, it's like a hyper jump, because successful SQL injections means that attackers just jump to the database, grab data, and jump back from the database, kind of omitting all our defenses. And again, in the real world, a lot of attacks occur because of insiders. I saw different numbers, depending on the industry, depending on how valuable data in this industry is. The numbers vary from 10–15% of attacks are made by insiders to 75%. So when you design your architecture, you should take into account all risks, including insiders risks, and including the point that insiders can actually be on every layer, like on any layer of your defenses. And usually people tell me like, hey, Anastasia, okay, we know all the things, but we already know a lot of security controls. We already are prepared. We are cool developers, we are cool DevOps, we are DevSecOps. We know all the things. And I have a question for you. Yeah, I agree, we know a lot of security controls. Okay. So these things that are actually real security controls, so real methods or tools or acronyms that are used in security, except one. Can you find the one? You are really quick. Okay. Yeah, RTFM, okay. So, do you know what IDS is? This one. IDS. Yes, intrusion detection system. KMS. Key management system. Okay. Nice. TDE. Transparent database. Transparent database encryption. Okay. Well, everything else is kind of easy. Okay, A. Authentication, authorization, and accounting. Good enough. Okay, so we already know a lot of security controls. We already have a lot of tools. And when we put all these tools in our typical distributed web application, we can have something like that. We can have means of active protection, like firewalls. And again, we have different kind of firewalls. We have WAF, web application firewall. We have data firewall. We have network firewall, right? Then, of course, we use access control, access restrictions for data. We use ACL for data in databases. We use secure coding practices for our application side. We use dependency management to check our packages, right? Then, of course, all the actions are being covered by logs, and we have something to monitor the logs. CEM system, security information and event management system. And then we have something to monitor the monitoring system, security. And probably we have some backups. And if we are lucky enough, the backups are working. And if we are lucky enough, the backups are encrypted, because it's a really good attack vector. And all these things, they are gonna work until they are broken. And usually in these, these systems, they are messy, they are chaotic. And usually we have a large company, or we have different people different teams responsible for each of the things, and they are not, they are not aligned. Sometimes these means of security, these means of protection are called checklist protection or checklist security. We call them band-aid security model. Go back. Animation, yes. I was working hard, okay? So, we call them band-aid security model. And developers often tend to think about them as about perimeters, like perimeter, and another perimeter. However, attackers, they think in graphs, and they construct a vulnerability path, and they move from a perimeter to perimeter, and eventually they will find vulnerability in each of these perimeters. And this is how attack graph looks like. So this is an example. This is a really old picture, example of some kind of infrastructures. We see firewalls here, IDS, an example of attack graph, and with vulnerabilities in each of these components, right? So let's get back to our system. We have already tons of security controls here, but it still holds a lot of risks and potential attacks. Application injections. Backend vulnerabilities. Remember all those Node.js modules that are not covered by monitoring, or we don't look or we don't read the results of monitoring. Misconfigured database access, my favorite. AWS S3 buckets that are left public, because why not, right? Even if they have this encryption checkbox. Then we can use TLS, fine. TLS, alternative protection measure. So we can use TLS, but if we obtain certificate from unreliable certificate authority, or if we have weak cipher suite, if we use TLS but we don't use a certificate pinning, right? Then, yeah, if we have backups but they are plain text, again, sorry, no, sorry. If we have a lot of logs, but at some point we have this log overflow, right? Cool to have logs, but bad if we don't pay any attention on them. So defense in depth says that, well, obviously, one security control is not enough, okay. But even when you have many of them, if they are chaotic, it doesn't make a lot of sense. You will get better results if for each group of risks, for each risk, you build independent but interconnected set of security controls. How to build that? First of all, again, we are talking about data protection. So on data level, we understand the data flow, how our data is being generated, processed, and where it's stored. It's nice to have security control that protects the data globally during the whole data flow. Then we find high attack vectors, like high risky paths in our infrastructure, and we build interconnected, overlapped security controls for these high risks, places of high risks. So we have like global controls, and then we have set of, overlapped controls for some points. Which global control, which tool, which methods, which mechanism we can use to protect the data during the whole data flow? The first letter of the answer is C. The second letter is R. Cryptography. Yes, we use cryptography because if data is encrypted, it can't be accidentally, suddenly decrypted. No, there is something, there is a place in the code, there is some service that will decrypt the data. And if we have data encrypted during the whole data flow, like field level encryption, data blobs level encryption, we can monitor the places where the data is decrypted. Then, cryptography, good implemented cryptography allows you to narrow down the attack surface and makes your data flow predictable. It's easier to monitor anomalies when you understand what's going on. And we build our tools around this idea that we use cryptography as a global layer of defense, and then we put other security control, like traditional security controls, to double, to triple protect the bottlenecks. Depending on the infrastructure, you can use different kind of cryptographic tools, let's say so. So if you have mobile or IoT based, IoT first infrastructure, you can build end-to-end encryption there. Unfortunately, if you have large web distributed apps, probably end-to-end encryption, it's not first thing to do for you. So for them, I will discuss right now another approach called Decryption Proxy. It's easy pattern. I don't want to explain the pattern from architectural perspective. Let's jump to our infrastructure. In Decryption Proxy says that there is some side that encrypts data, and there is another side, Decryption Proxy, that decrypts data. So you kind of separate encryption of decryption. Why? Why? What's bad? What's wrong to encrypt and decrypt data at the same component? if we use simple symmetric encryption, we have one key to encrypt and decrypt data. What's wrong with encrypting and decrypting on the same component?
Once the key is compromised, anybody can use it.
Yes. This is why database level encryption doesn't make a lot of sense, because anyone who has access to the database server has access to the key, right? There is nothing wrong to have encryption and decryption on the same components, but we kind of add more trust to the infrastructure if we separate them, so we can do encryption on a client side, but decryption on a trusted zone, a trusted environment that we monitor. That's easy. And this makes the data flow very predictable, right? So we have one way, we have writing data or encrypting data, and we have another path, another way when we read data or decrypt data. So again, predictable things are good for security because it's more easier to analyze anomalies and to understand what's going on. I know it's maybe a little bit high level. And let's get back to our super cool infrastructure. So, how to build decryption proxy and this data flow? We separated our application backend to two different components to do different services. The application backend itself will make client-side encryption. Okay, I'm from traditional cryptography. I don't believe in cryptography in web browsers yet. So from cryptographic perspective, client side is actually application side. So we will have client-side encryption in our application backend, and we will have decryption in a separate component, in a separate service, decryption proxy. When data, the writing data flow, the data is being generated somewhere, it gets to application backend, it's being encrypted and sent encrypted in our infrastructure, and is stored encrypted in a database. To read data from the database, we need to make read requests through decryption proxy, which obviously works like proxy. It redirects request to the database. It gets encrypted response. It decrypts the data and redirects response back to the client side. What is fun here? The key model. We don't use one key anymore. We use public key to encrypt the data, and obviously, application backend doesn't have a private key to decrypt the data, only public key. And we use private key to decrypt the data. And of course, we store private keys in a very trusted zone, in some HSM, in your KMS, well, it depends. And as soon as application backend and database, they don't have private key, they can't accidentally decrypt the data. Technically saying, the key model is a little bit more complex. This is a key model from our software we use. So it's more than one key, and of course you can't have private keys, plain text as well, so you can encrypt private keys as well. So I can elaborate on that, or I can skip the slide and continue without digging into multi-layer encryption. Okay, I see your faces. Okay. If you're really curious in terms of ciphers, in terms of encryption, how it works, let's just discuss it after session. Let's move forward. When we separated encryption and decryption, we make it more complicated to break our system, to compromise our system, because database actually doesn't know what is the data that is being encrypted, right? Database doesn't have any keys, doesn't have any clue. Breaks the database, all fine. Application doesn't know a way to decrypt the data, so maximum you can get the data generated on this app, like its own data, if you break the app. However, defense in depth, encryption itself is not enough. And let's get back to the world of these other shiny security controls we know, and add them into our database. Because cryptography was first, like global layer of defense. We need something, we need to double and to triple the defenses. What we can have here, first of all, yeah, TLS, nice. Then on our decryption proxy, if you think about it, it's the only point that decrypts the data. So on this point, we can have some authentication. Decryption proxy has requests from a client side, and it authenticates, does this client has right to access this data? No? Then SQL firewall, if we're talking about SQL databases, of course. We get some requests that ask us to select all from database. Does it make sense? No, stop the request. Then we use which is called compartmentalization, like different zones, different keys for different clients, for different users maybe. So when we get a request from a client with these keys, please decrypt me data with these keys, this decryption proxy checks, okay, probably the keys are wrong. You can't ask to decrypt data from other user if you have this key. Stop. Then, which is also useful, honeypots or honey tokens, as we call them. So in our database, inside encrypted records, we can have a special markers, a special records that look completely the same, because it's encrypted, right? It doesn't make any sense for humans, for attackers. So records that look completely the same, but these records should not be read by this client. So when proxy makes request to the database and gets in database response, gets data with these markers, it means that actually someone already broke our SQL firewall, and this is like not authorized request actually, and this decryption proxy can stop this request. So all these things are traditional security controls, not cryptography. Traditional security controls we can put into our infrastructure to help cryptography. Because cryptography is like not a magic wand, it's not like that. We need to do all the traditional stuff as well. Got it, right? Intrusion detection, firewalls, KMS, all different like transport layer encryption, yada yada. Let's go back. Yes. And the third point is very important, that the data is being watched. As soon as we understand the data flow, we can build these monitoring tools and audit logs, for example. We can write to the logs that the data was accessed by user X with key something something. So if in case of incident, we have audit logs as well. And when you're building a system that has cryptography as its as a first layer of defense, you can actually have a lot of useful data for your CMs, for your monitoring tools, right? And if you see some peak of decryption operations in your CM, that's probably anomaly. That's probably someone has broke through your system of defenses and got a lot of data and starts decrypting this data. So you have tools to understand what's going on here. And as I mentioned previously, it gets a little bit complicated, just a little bit complicated to compromise the whole system, because the only like valid way to get decrypted data, to get data in plain text, is to read it through decryption proxy. Otherwise, you need to compromise the backend application to go through the SQL firewall, through intrusion detection system to handle all the different keys for different users. And then, of course, not to leave anything in logs and not to trigger any monitoring anomaly detection events. So this is called defense in depth. And these are layers of defense around data we just discussed. From a data itself, we use encryption of like data pieces for separate data pieces, just as simple. In our case, for example, we use IIS GCM. So simple, traditional, strong encryption. Then we use different keys for different clients, which actually works as authentication, as access control, because you can't decrypt data that you don't have key for that. Then, of course, we still have this transport layer encryption, TLS, or in the case we are not linked to TLS, we can have new modern cool cryptographic protocols like libsignal, for example. And then there's the monitoring layer. For me, it looks really similar to this one. Do you know what it is? Yes. You see PM in our room, huh? Yeah, this is a transatlantic cable. So the cable itself, this is its core, optical core. And all other things are layers of defense. And the last one is, the last cover is actually a shark protection. Because you know, sharks, they like cables. Okay. One more point about defense in depth. How to build, how to start thinking in terms of defense in depth for your infrastructure. Try to think that your data is your money and you're a bank. So, as a bank, you save your money somewhere in a bank vault, right? And for us, it's, for example, can be AWS bucket, S3 bucket. This is your vault. And you have this file protection encryption, like file level encryption, S3 bucket encryption, cool. This kind of door of your vault. And usually, if you think about bank robberies, not so many people try to steal data from storage, from vault. Either you are insiders and you have a keys, or usually you understand that the means of protections are quite high. How people usually steal money? File transportation. That's why when you get your data from your S3 bucket and try to process it, to calculate something, you need to build all these defenses around your data. Because similar to defenses people build to transport money, right? They have a special armored cars. Then on these cars, they don't have external locks to open doors from external side. Then they have trained people with officers with guns. They have special bags to put money in. And of course, they have this radio to communicate with each other, and they know the route. So someone is watching them. And you can think about these as about layers of defense around your data. Of course, if application you make operates with sensitive data, with valuable data, because if you create Instagram for kittens, I understand everything. These things probably are not for you. Okay. So again, defense in depth is how to build system with defense in depth approach in mind. You need to have one global security control, which is cryptography. Cryptography is really cool for that. And then you create independent but overlapping interconnected set of traditional security controls. Kittens in tinfoil hats. How to build it? How to build this kind of system? First, of course, you can build it on your own. I mean, you're cool engineers, you can build those things from scratch. Just one small advice, start from security design. Start from trust model, risk model, and potential attacks to understand the data flow of your system. Then you can use box solutions. For example, if you use Oracle. Someone is using Oracle here? So, no, okay. So, in a case you are using tools from one large vendor, usually those vendors already have a set of tools that you can use paying them. For example, in Oracle suite, it's not only the database itself, right? Oracle has TDE, transparent database encryption, and Oracle has SQL firewall. So if you stick to one vendor, probably vendor already has some kind of things. If you don't, Fortunately, there are like a lot of open source tools available. The one I showed, the orange one, is Acra. You can use it as decryption proxy, as something that will decrypt and encrypt your data with, of course, client-side libraries to encrypt data. If you don't want to use Acra, you can use, for example, Green SQL. It's a SQL firewall. Then Lipsodium, it's a cryptographic library, and build in this cryptographic library into your own decryption proxy. Well, it depends on your level of how many things you want to do yourself. You can use separate IDS, intrusion detection system. Well, CMs are usually separate tools. And all these things, like most open source tools, you can use them on your, like if you use Docker, if you use Kubernetes, most things are already there. The one I showed you is Acra, open source, free. And if you use Docker, it's compatible with Docker, it's compatible with DigitalOcean. And if you want to, do you want to have a, okay. Yes. Okay, awesome. And if you build the system, like this kind of system we just discussed, you already can cover these things from a WASP top 10. Okay. Okay, you deserve a kitty. You survived the cryptography talk. And these are key points. When we are talking about data security, we are talking about money that we as a company can lose. Why? Because regulations are pushing on the market, because of the huge fees, or the huge fines, sorry, because regulations are pushing on service providers like Google, Apple, Amazon, and we use services from those providers. And I predict that those providers will push even more on companies that use them in terms of like data protection, security assessments, yada yada. Then defense in depth itself, it's not something new, but when we are talking about defense in depth for data, we are talking about building a system that watch data with like different, like, different entities with different layers. And these layers, they are not only chaotic, because we already know a lot of security controls. They're not only chaotic, but they actually connected with each other. Then cryptography is a good thing to start, because when you have encrypted data, it can't be suddenly decrypted. And you can watch these places where you decrypt data. And it's 2019 already. There is an app for that. There is a tool for that. Most likely you'll find out that there are tools from vendors, there are open source tools, and you can try them, you can use them, you can build them into your systems. And I know you like security a lot. And you like reading about security a lot. So I prepared a list of articles for you. So you can read them, in long evenings. Like, why not read about security? Actually about defense in depth, about backend security, database security, yada yada. And of course, you can follow me on Twitter. And if you are curious, and different like cryptographic tools, check our site. I think that's all. Yeah, I think that's the last slide I have, and it's perfect timing. So thank you for the attention. Thank you for that. Yeah, I know, overwhelmed a little bit. Now we need to go to the separate area for discussion, right? Oh yeah, that's very important. On your tables, you can find these old school physical cards. And you can put your feedback on those cards, which will help JFrog to build better conferences and maybe to invite me more to speak. Yeah.
They're not encrypted. What should we do?
Trust, is there plain text? Don't put your sensitive data there. All encrypted. Okay, so if you want to talk about cryptography, database encryption, or searchable encryption, my other topic I really like, searchable encryption, how to have data encrypted but still searchable, just follow me to the discussion area somewhere here. I have no clue. Okay.
Thank you.
Thank you. Oh, second round of applause. Yes.